Understanding neural networks, a comprehensive overview. Neural networks are a subset of machine learning algorithms designed to function similarly to the human brain, allowing them to recognize patterns and make predictions based on vast sets of data. This article will delve into the concept of neural networks, their history, types, applications, advantages and disadvantages, and how they operate within a broader financial context. What is a neural network? At its core, a neural network is a series of algorithms that mimics the way the human brain processes information. It consists of interconnected nodes, often referred to as neurons or perceptrons, which work together to analyze data, recognize complex relationships, and produce desired outputs. Neural networks can adapt to changing inputs, generating optimal results without needing manual adjustments to their configuration. The analogy between neural networks and the human brain lies in their structure. Neurons in the brain communicate through synapses, while nodes in artificial neural networks are connected and communicate with one another through weights. Key features of neural networks. Adaptive learning. Neural networks can adjust to new input data, enhancing their predictive capabilities over time. Layered structure. They consist of multiple layers, input, hidden, and output, which allow them to process data incrementally. Deep learning. Networks with many hidden layers are termed deep neural networks, DNNs, which are particularly powerful for complex data processing tasks. Historical context of neural networks. The concept of neural networks is not new, it has evolved over several decades. 1. 1943, the early foundations. Warren McCulloch and Walter Pitts outlined a model for artificial neurons, establishing the groundwork for later neural network theories. 2. 1958, the perceptron. Frank Rosenblatt introduced the perceptron, the first artificial neural network designed for image recognition. 3. 1980s, rebirth and expansion. After a period of stagnation, advancements in backpropagation and recurrent networks revitalized interest in neural networks, with researchers like Paul Werbos and John Hopfield contributing significantly to the field. 4. 1990s present, real-world applications. The advent of powerful computing technologies enabled the use of neural networks in various fields, from finance to healthcare, enhancing their practical applications. Types of neural networks. Neural networks come in various forms, each suited for different tasks. 1. Feed-forward neural networks, FFNN. These networks transmit information in a single direction, making them suitable for straightforward classification tasks, such as image recognition. 2. Recurrent neural networks, RNN. RNNs have connections that allow them to use previous outputs as inputs, effectively providing them with memory of past data, which is crucial for tasks like speech recognition. 3. Convolutional neural networks, CNN. CNNs excel in processing grid-like data, particularly images, by applying convolutional layers that capture specific features related to the input data. 4. Deconvolutional neural networks. These networks work in the opposite manner to convolutional networks, often used for tasks such as image generation and analysis. 5. Modular neural networks. These consist of different networks that work independently on specific tasks, optimizing performance while managing complexity. Applications of neural networks. Neural networks have found extensive applications across numerous industries. Financial sector applications. Time series forecasting, predicting stock prices and trends based on historical data. Algorithmic trading, automating trade execution based on neural network assessments. Risk assessment, evaluating credit risks and fraud detection based on transaction patterns. Marketing research, analyzing consumer behavior and predicting sales trends. In financial contexts, neural networks can evaluate and process enormous amounts of transaction data, identifying patterns that can guide investment decisions. This capacity for analysis surpasses traditional statistical methods, enabling better asset class movement predictions. Advantages and disadvantages of neural networks. Advantages. High efficiency, neural networks can process and analyze data much faster than humans. Continuous learning, they adapt based on prior outputs, striving for improved future performance. Versatility, their applications are expanding, extending beyond finance to fields like medicine, science, and security. Disadvantages. Complexity, developing specific algorithms can be time-consuming and require expert knowledge. Lack of transparency, some neural networks function as black boxes, where the reasoning behind decisions can be difficult to interpret. Hardware dependence, there is a reliance on physical systems, which can introduce risks regarding maintenance and failure. Components of a neural network. A typical neural network is structured around three main components. 1. Input layer, where the raw data is fed into the network. 2. Processing layer, the hidden layers that perform computations and apply transformations to the input data. 3. Output layer, the results of the computations, representing the predicted outcomes. Deep neural networks, the next level. Deep neural networks are characterized by structures containing multiple processing layers, leading to enhanced learning capabilities through complex feature extraction. These networks leverage machine learning techniques to evolve continually by comparing predicted outcomes to actual results, thereby refining their predictions. Conclusion. Neural networks represent a sophisticated intersection of data analysis, computation, and predictive modeling, creating opportunities across various domains, particularly in finance. They are capable of identifying intricate patterns within data that could reveal insights inaccessible to simpler analytical models. As technology advances, the applications and capabilities of neural networks will likely continue to expand, further transforming industries and practices.